Maybe. There we go. Hi, everyone, and welcome back to another Planetarium show. My name is Jessica. I am the director of the Planetarium, and with me tonight is one of our students who I will let introduce himself.
Hi, my name is Eli. I'm a physics and astronomy student at UMD.
So tonight we are going to be taking you on a tour of a group of objects known as the Messier objects. These are pretty common. A lot of people may have heard of these or maybe heard something, one of the references and may not know what it is. We're going to tell you all about that tonight. What this group of objects is, the different types of objects in it, and some of the really cool and brighter, easier ones that you could go out and find yourself. So, if you do have any questions throughout the show tonight, feel free to leave them down in the comments. Eli is going to be keeping an eye on those for me and will let me know when anything pops up. If we don't get to them right away, we can also take questions at the end of the show as well. All right, so there we go. I'll switch over. So as I said, we are going to be talking about Messier objects tonight. So there are 110 objects that are known as Messier objects. You may have heard of them. They're often referred to as M and then a number, which is the number in the Messier catalog. So M1, M12, M42, any object like that that you've heard called M and then a number is a Messier object. And these are astronomical objects that are outside of our solar system. Some are objects within our galaxy, some are galaxies in their own right. But there are, as I said, 110 of them. These tend to be fairly bright objects. Some of them you can see with your naked eye, but all of the rest you would need just a pair of binoculars or a small telescope to see. You don't need anything super fancy to be able to see all of the Messier objects. All right, now the Messier objects were discovered, or not so much discovered, but cataloged by the French astronomer Charles Messier. He wasn't actually looking for these objects, so he was actually interested in studying comets. But as he was searching the skies for comets, he kept coming across these other things that weren't comets. And as this continued to happen to him, he decided to make a list of all of these objects and their coordinates so that he would know, don't look here because that's not a comet there, that's something else. And so by 1774, Messier and his assistant, so Messier is on the left, his assistant is on the right. His assistant is Pierre Machain, I think is how you say it. I don't speak French. Um, but they came up with the first draft of this list, which included about 45 objects. Since then, more have been added to get to the total of 110 objects that are on the Messier list today. And for night sky enthusiasts and amateur astronomers, the Messier objects are a fantastic group of things to try and see with your telescope. Again, because they are pretty bright, that makes them easy to find. There are different Messier objects up throughout the entire year. And they are, the one downside though is they're really only mostly northern hemisphere objects because Messier was in France. So they don't include any southern hemisphere objects. And so they're good for us here in, the northern hemisphere, but any amateur astronomers or night sky enthusiasts would not necessarily be able to see all of these if they live below the equator in the southern hemisphere. All right, now, as I said, there are a number of different types of objects that are within the Messier catalog. The first type of object that we can find are what's known as an open star cluster. So stars often are not alone. Most stars form in a group along with many other stars. And so we find stars grouped together, and there are generally two main types of groups, with the open star cluster being one type. These tend to be much smaller groups of stars, so we're talking a few hundred up to a few thousand stars, and they tend to be more loosely bound together, so they're a bit more spread out or open, hence the open star cluster. These groups of stars also tend to be younger populations, and so they tend to have a bluer appearance to them because the blue stars live for a shorter period of time, and so we only see them in young clusters like these. And so the most famous open star cluster is the Pleiades star cluster, which is currently up. It is one of the winter objects that we can see, and the brightest of the Messier objects that can very easily be seen with your naked eye. Even in decent light pollution, you can still see this. And so it is right next to the kind of V shape of the head of Taurus. We can find the Pleiades star cluster right there. So the other type of star cluster is a globular cluster, which looks like this and looks quite a bit different than the open star cluster. So a globular cluster is named so because it is a giant glob of stars. Instead of having a fewer number of stars like the open cluster, the globular clusters contain anywhere from hundreds of thousands to millions of stars grouped together in a kind of spherical or glob distribution, and that tends to be much more heavily concentrated at the center, and you get kind of fewer stars as you move out from the center. You'll also see that these tend to not be quite as bright blue. They tend to be more kind of yellow or reddish, and that's because these in general are older populations of stars where those big blue stars have died, and so we're not seeing the light from them. We're seeing the light from red stars, which live for longer periods of time. So this is a classic example of a globular cluster. This is M2, also known as NGC 7089. This one doesn't have a super fancy name to it. And this one is in the constellation of Aquarius. So this is kind of more fall time that you can find this one. But if you can find the kind of legs of Aquarius that straddle this triangle of Capricornus, then you can find M2 just above that right leg. I will stop to note here that you'll see that for these objects, I'm including this sort of star chart or star map to show you where they are. And that's because many of these objects you can't see with your naked eye. And so in order to find them, you have to use things that you can see so that you can pinpoint where to point your binoculars or telescope. In this case, it would be finding, say, these two bright stars and kind of following that line up to find where M2 is. And that's why some of these are more, we'll say, intermediate objects for an amateur astronomer or anyone interested in looking at objects, because you do kind of need to have somewhat of an understanding of the bright stars that are out so that you can better read these star charts and know how to find what you're looking for within them. The other thing I want to note is the really, really pretty pictures that I'm showing you right now aren't necessarily what it's going to look like through the binoculars or through your telescope. These are taken with cameras that are able to stay open or stay exposed for longer periods of time than our eyes can. And so it's able to collect more light than our eyes can. And so it may look a little bit different. A bit later on, I have some other objects with a bit more accurate representation of what you would see through a telescope. But when just kind of going over these the different types of objects, I wanted to have an excuse to show some pretty pictures. I mean, it's gorgeous, right? I love these. All right, so after my little side note, let's move on to some of the other types of objects that we can find. So in addition to star clusters, there are also a bunch of gas clouds in space, and we call a gas cloud in space a nebula. The plural is nebulae. And for our nebulae, there are three main types that you can see. The first that we're seeing here is known as a star-forming region. And that's because it is a giant gas cloud that is actively forming stars. So when I say giant, I'm talking, hundreds to thousands of solar systems worth of material in this cloud. Huge. The most famous of which is M42, also known as the Orion Nebula, because it is in the constellation of Orion, which is currently up in the winter. And you can find it in his sword hanging off of his belt here. This kind of middle point of light in his sword is actually this beautiful nebula. Now, the picture on the left is a bit more realistic for what you would see. I personally love showing people the Orion Nebula through a telescope because I think it's one of the ones that still looks really awesome without having long exposure cameras and stuff, because you can still see all of the kind of nebulosity, the cloudiness, and even with your eye, you can start to pick up some of those colors that are there as well. And so it's gorgeous to look at and very easy to find because the belt and the sword of Orion are pretty prominent, and so it's an easy landmark to look for. In fact, if you are in super, super dark skies, you can actually see the Orion Nebula with your naked eye. You don't have to have a telescope. I personally have never been able to see it, not for lack of dark skies, but just my vision is not great. But it is a great winter object to look at and probably one of my favorite objects to see in the night sky. Okay, so the other two types of nebulae are related to the deaths of stars. So star-forming regions are gas clouds involved in the birth of stars, but our next two are involved in the death of stars. And so our next is what we call a planetary nebula. And this name is a little bit of a misnomer because it doesn't really have anything to do with planets. But let me tell you what it is first, and then we'll get into why it was named this. So this is what happens to stars that reach the end of their lives that are small stars, so something like the size of our sun or smaller. As they reach the end of their lives, the outer layers start to puff up. And as those outer layers puff up, the star grows into what we call a red giant star. But because those outer layers now sit further away, the star's gravity has a weaker hold on them. And eventually those outer layers end up puffing out, and the star loses its grasp on them, and they float out and away. And so over time, we end up with the just dead core of a star left behind, surrounded by a sphere of gas that are those outer layers that puffed up and then floated away. That core in the center that's left behind is what we call a white dwarf. And that glowing spherical gas that surrounds it is the Planetary Nebula. And so, again, this is what our sun will do at the end of its life in about 5 billion years or so. Now, the reason this is called a planetary nebula is because of how it looks in a telescope. You see this disk of usually kind of bluish light, which is very similar to how Uranus and Neptune look through a telescope. And so it was named because of the similarity in appearance, but not because it has anything to do with planets. So this particular planetary nebula that we're seeing is known as the Ring Nebula, which makes sense, right? It looks like a ring of gas. And this one is up in the summer. You can find it also noticed, there it is, in Lyra the Harp, right in between two of the stars that make up Lyra the Harp. All right, and then the last type of nebula is what happens when a massive star dies. So when a massive star dies, it goes through a much more dramatic death where it actually explodes in what we call a supernova event. And all of that gas that made up the star gets expelled out in this giant explosion and ends up moving out away from whatever may have been left behind, like a neutron star or a black hole, and ends up moving away because of this explosion. But it's also really hot at the time, and so it glows. So this glowing gas that's expelled out in the supernova explosion creates what we call a supernova remnant. One of the most famous is what we're seeing here, M1, the Crab Nebula. This one is particularly famous because it is actually one that we saw the supernova occur for. I say we, I don't mean to say we. Early astronomers saw the supernova occur. So this one happened back in 1054. And Chinese astronomers actually noticed this new bright point of light in the sky that hung around for a few weeks before disappearing again. And based off of where they placed it on their star charts, what we see in that location is the Crab Nebula, telling us that the Chinese astronomers saw the supernova that left behind this supernova remnant of the Crab Nebula. And because we have been studying it for a while, you can actually see over many decades, the nebula has grown because that gas is still exploding. It's still flying out and away from where the star was. And so we can watch as it moves and grows. And that gives us some insight into how fast this gas cloud is moving and how energetic those supernova events are, which is really cool. Now, the Crab Nebula is up in the winter sky. It is also right in the constellation of Taurus, just like Pleiades is. But this one is right near its left horn. And so you can find it right next to the star that makes up its left horn. All right, so the last types of objects that we can find up in the Messier catalog are galaxies. And galaxies come in a couple of different types. The two main types of galaxies are spiral and elliptical. So a spiral galaxy is just like the galaxy that we live in, the Milky Way. It's a disk that has spiral arms in it, and at the center sits a roughly spherical bulge at the center. And so here's a classic example. This is M33, the Triangulum Galaxy, which is in the constellation of Andromeda, so up in kind of the fall. And because the spiral galaxies are shaped like a disk, how they appear to us very much depends on how that disk is oriented. So some of the galaxies we see kind of face on, and so we can see the full kind of disk and see that beautiful spiral structure in it. But some of them are a bit more edge on. And some are in between, like we see with the triangulum. So what we specifically see depends on how that galaxy is oriented with respect to us. And then the other type is the elliptical galaxy. And it's called this because, well, it's a giant kind of spheroid or ellipsoid of stars. It's a lot like a globular cluster, but on galaxy scales. And so you see this roughly spherical distribution of hundreds of millions, billions, even trillions of stars. M87 that we're seeing here, which is up in the summer, you can see it right here. It's right in the middle of a big cluster of stars, or not stars, a big cluster of galaxies. So there's a lot to see around it. But I picked this one because M87 is one of the largest elliptical galaxies. It's also a little bit peculiar because you can see it has this jet streaming out from the center. And that's because the supermassive black hole that sits at the center of this galaxy is actively feeding on gas and stars and stuff, and that creates this jet of material. In fact, if you remember, I say not long ago because it feels like not long ago, but I think we're at least a year now, maybe a year and a half. We had the news break of the very first black hole that was ever imaged, and that was the supermassive black hole at the center of M87. All right, so those are our main types of objects that make up the Messier catalog. I want to take you through a few others and show you a bit more realistically what they would look like. So one of my favorite summer objects is the globular cluster M13, known as the Great Globular Cluster in Hercules, because he sits right in between the shoulders of Hercules, or no, legs, sorry, Hercules is upside down, sits right in between the legs of Hercules. And so this is more of what it would actually look like through a small telescope. This is one of my favorites because with globular clusters, because there are so many stars, they end up almost looking like a sparkling jewel because of all of the stars really close together. And it's beautiful. I love it. They're great to look at through telescopes. And as you can see here, even with a small telescope, you get a really cool view of that. Another fun one to look at is the Dumbbell Nebula, which sits in, why am I messing up? Vulpecula. It says it right there on my slide. It sits right here, right kind of in between Cygnus the Swan and Aquila the Eagle. This is a planetary nebula that has this distinct kind of dumbbell or hourglass shape to it. And you can see that through a small telescope, you can see that shape and even get some of the color in there as well. Anywhere overlooking into the Milky Way, you're going to find a lot of nebulae as well, because a lot of the gas clouds are concentrated in the disk of our galaxy. So you can find things like the Lagoon Nebula, or the Trifid Nebula, which is right up here, which is a really cool one because it's got this like two-toned color to it. It might not look quite as vibrant as this, but you can still get a sense of the kind of red and blue tone to it when you look at it. And then another great one to look at in the fall, which you don't need a telescope for, is the Andromeda Galaxy. It's right here near the constellation of Andromeda and the square of Pegasus. A tip to find it is to use the W of Cassiopeia and use the top part of the W as an arrow to point you to this fuzzy blob that is the Andromeda Galaxy. And as I said, you don't need a telescope to see this one. It is bright enough to see with your naked eye if you have some decently dark skies. It'll look just like a little fussy blob, but if you're able to look at it through a telescope, you'll start to see a little bit more definition and a bit more of the structure and true shape of it. But it's really cool. It is the farthest object that we can see with our naked eye without a telescope, which is really cool. All right, before I wrap up, I want to show you a really useful tool if you're interested in kind of taking an observing night and you want to try and figure out what's going to be up, where it's going to be, and kind of plan out your observing. A great tool to use is this program called Stellarium. If you've been to some of our shows in the past, you have heard me talk about this. It is a free program, and in fact, I have the link for it down in the video description. But it works very much like a planetarium. You give it a date, a time, and a location, and it shows you what the sky looks like. And so I have it set up for Duluth at about 8 o'clock at night. And you can do a lot of things with this. It'll show you the names of bright stars. It'll show you constellations, if you're interested in that. It'll show you which planets are up. But the other thing you can do is turn on these deep sky objects, which are what we've been talking about, these things outside of our solar system, and it'll show you where they are. And so here we can see, where am I at? It'll just, there we go. Right over here in the Sword of Orion, and I can turn on the constellation lines to make it a little bit easier. We have the Orion Nebula. Up here, following the belt of Orion past the V of Taurus, we have the Pleiades star cluster. In between the horns, right near the left, is that Crab Nebula. And you can zoom in to see pictures of it. You can click on it and it'll give you information about it. And so you can see that, we only touched on a few of these objects, but you can see that there are a lot up right now. Here we have some galaxies that are up in the kind of northeast. The Beehive cluster is a really cool globular cluster. Or open. Open? Yeah, open. My bad. So just lots of cool things. And you'll even notice that the symbol kind of tells you what it is. So this kind of starburst is a star cluster. The green square is a nebula. The red oblong circle is a galaxy. So this is a really, really useful tool and can help you plan out your observing and kind of get a sense of what you're looking for, and plan that out. So I just wanted to show you this tool as well, because it's really great, and it's free, which makes it even more awesome, and just super powerful tool to use. All right, so that brings me to the end of all I had planned. Do we have any questions, Eli?
Nope, just a couple people saying that they liked the presentation.
Awesome. Well, I'm glad you enjoyed it. If you do have any questions, feel free to go ahead and leave them down in the comments. We'll spend a few more minutes to see if anything comes up. And while we're waiting, let me tell you about our upcoming week. So on Wednesday, we're going to be doing a special show called the Starry Birds of Inauguration that's going to be led by Jim Rock, who is our Director of Indigenous Programming at the Planetarium. It's a really interesting take on how ancient cultures used birds to kind of predict or to get good or bad omens. And they used that to tell a lot of things, like whether a new ruler was going to be good. I don't want to spoil much, but it's a really cool show, and we thought it was appropriate given Wednesday is Inauguration Day. And then next Saturday, we are going to be doing another edition of Ask an Astronomer. So bring us your questions and we will answer them for you. Or try and stump us. I don't think we've been stumped yet, but I'm waiting for the day. It'll happen. I know it'll happen.
We called in our pinch hitter Google once or twice.
We have, that's true. She's not supposed to give away our secrets. But then we also have, we are now offering private virtual shows if you are interested. We've done several of these already. We've done a few for virtual birthday parties. We've also done some virtual field trips. They've been a lot of fun, and we just are excited to get back doing some more one-on-one stuff with people. But all of the details on that you can find on our website. And then lastly, we still have our solar distancing t-shirts for sale. This is helping us to raise some money since we have been closed since mid-March. But yeah, if you like what you do and you want to support us and are interested, head to our website. There's a link in the description and you can get one for yourself. They're really awesome. I have to say it, I guess, because my husband did design the graphic for it. But I still unbiased think they're pretty awesome. But I'm checking. I'm not seeing any questions, although Eli, sometimes you see them when I don't.
Nope.
No? Awesome. All right. Well, thank you everyone so much for joining us. We hope you enjoyed the show. Have a wonderful rest of your weekend. Yes, because it is Saturday. I'm still losing dates sometimes. Have a wonderful rest of your weekend, and we will see you next time. So, bye everyone.